Hello friends, today I am going to talk about query decomposition. Mapping of calculus query to algebra operations such as select, project, join, rename is called query decomposition. Both input and output queries refer to global relations without knowledge of the distribution of data. The output query is semantically correct and good in the sense that redundant work is avoided. Now, types of query decomposition. First, normalization. It transforms query to a normalized form. Second, analysis. It detects and rejects incorrect queries, possible only for a subset of relational calculus. Third, elimination of redundancy. It eliminates redundant predicates. Fourth, rewriting. It transforms query to relational algebra and optimized query. Now let's discuss what is normalization. It transforms the query to a normalized form to facilitate further processing. It consists mainly of two steps: lexical and syntactical analysis. It checks validity similar to compilers. It checks for attributes and relations, type checking on the qualification. Second, put into normal form. With SQL, the query qualification, that is where clause, is the most difficult part, as it might be an arbitrary complex predicate preceded by quantifier. Now I will explain normalization with the help of a video.
Hello friends and welcome to Study Tonight. In this video, we will try to understand the concept of normalization in database. We will start with understanding what all problems arise if a table or a database is not normalized and how normalization solves these problems. So what is normalization? Normalization is a technique of organizing the data into multiple related tables to minimize data redundancy. Now you would ask, what is data redundancy and why should we reduce it? Well, data redundancy is nothing but repetition of similar data at multiple places. And we want to reduce it not just because repetition of similar data multiple times eats up extra space, but it also leads to multiple other issues like insertion, deletion, and updation anomalies. For now, let's start with a very basic example and try to understand data redundancy and the problems that we face due to it. So here we have a simple student table to store student information in a college. We have columns: roll number, student name, the branch or the department name, the name of the HOD or the head of the department, you can call it a teacher name as well, and the department telephone number. Now let's put data of 4 computer science students into this table. We'll add roll number 1, 2, 3 and 4, put in the student's name, their branch name, the name of the HOD and the department telephone number. Now in this case, the branch name, the HOD name and the telephone number are same for all the entries that we make. Whenever a new student entry is created, this entire information is repeated, and this is what is redundancy. Now this data redundancy not only increases the size of our DB unnecessarily, but it also leads to multiple other issues like we talked about. So let's see what these issues are. There are 3 main problems that data redundancy causes. These are the insertion anomaly, the deletion anomaly, and the updation anomaly.
Now let's discuss what is analysis phase in query decomposition. Analysis identifies and rejects type incorrect or semantically incorrect queries. Type incorrect queries. Checks whether the attributes and relation names of a query are defined in the global schema. Checks whether the operations on attributes do not conflict with the types of attributes. Example, a comparison operation with an attribute of type string. Second, semantically incorrect queries. Checks whether the components contribute in any way to the generation of the result. Only a subset of relational calculus queries can be tested for correctness, that is those that do not contain disjunction and negation. Typical data structures used to detect the semantically incorrect queries are connection graph and join graph. Now, let's discuss the final steps of query decomposition. Elimination of redundancy. Elimination of redundancy simplifies the query by eliminating redundancies, example redundant predicates. Redundancies are often due to semantic integrity constants expressed in the query language. Example, queries on views are expanded into queries on relations that satisfy certain integrity and security constants. Now, rewriting. It converts relational calculus query to relational algebra query and find an efficient expression. A query tree represents the array expression. Relations are leaves and result attributes are root. Intermediate leaves should give a result from the leaves to the root. Now following are the abbreviations that I have used in this video. SQL, Structured Query Language, Array, Relational Algebra. And following are the sources from where I have used to make this video. Thank you.